geometry. We want to go through and we want to talk about getting all of this distance between a point and a line taken care of. I know some of you are going to be gone for the FCCLA deal, so that's why I'm making this video is for you. First period and second period got to different spots. So what I'm going to do is I'm going to make the video for first period. So if you're a second period student and you need to watch this, you can kind of skip ahead near the end. So let's get going here. We talked about this stuff today in class. So the distance from a line to a point not on the line has to be that perpendicular line. So then when we did it in our deal here, for KLN, we just had to draw the line straight down to KN. For the ABCDE, we had to extend the AE out and then drop it down. Okay, then what we were getting to was this thing right here, and when we started to construct it doing this. So we got to this point. Now what we have to do is we need to figure out what this point right here is. And we have this point right here. So I got the -1, -5, which is the point given to us in the problem. And I got to find out what that point is. Well, I can see it on the grid. It's 1, 2, 3. So it's a -3, 1, 2, 3, 4, -4. I need to find how far apart are these. That's the distance formula. So that means I want to use the distance formula. x2 minus x1 minus y2 minus y1. So -1 minus -3 squared plus y2 -5 minus -4 squared gets me a +2 squared plus -1 squared. Notice I always put them in parentheses until after I square them. Should do that all the time. So that gets me a 4 plus a 1 square root. So it's the square root of 5 units away, which is around 2.24 units. Now, could I have done it a different way? You betcha. I could have. Let me just do this whole thing. I'm going to take this out, take that rings out. I'm going to take out these marks here too. And it's something that was discovered during second period. Whoops. Discovered during second period is, hey, you know what? We knew what the slope of the line was for this. The slope was 2/1. So that means for the line I need to do from our red point here, from this point, is I need to use the perpendicular slope, which would be -1/2. So from our point, if I go down 1/2, I can have the line 2, and I'll draw it back this direction. But now the trick is, I really only need this segment right here. And that segment, I have a length right there. So that's what we can do. So you can actually use a compass, or you can use the perpendicular slope part. Okay, so a couple of definition type things here to go with. I'm going to switch to the magic pen, just so we can write that out. Okay, so by definition, two parallel lines, yada, yada, yada. So I can rephrase the whole thing saying two lines in a plane are parallel if the distance between the two lines measured along a perpendicular line always remains the same. So as long as every one of these lines, no matter where it is, stays the same, the lines are also parallel. That's very useful, but I need to know what is that distance. What is that d each time? Now, here comes our neat little theorem right down here, I guess you can say, or a concept. That is not the one I wanted. Concept there. The distance between two parallel lines is the distance between one of the lines and any point on that line. One of the lines and any point on the other line. Any point on the other line. So we just have to find a point. So here we have, in a plane, if two lines are equidistant from a third line, then the two lines are parallel to each other. So a nice little theorem right there to worry about and to think about. Make sure you get that written down. Hopefully you're watching these videos and you're actually getting notes written down on these. Okay, now our next thing, we're going to get a problem that looks like this. And we've got to be able to figure it out. Now to do this, we have two options. Option 1. Is the graphing option. So what we do in option 1 is we graph the two lines and we get a point on one of the two lines, and then we do like we just did and we find all those information from it. Okay, so let's try that real quick. Graph the top line. I'm going to graph it in blue. So it's got a y-intercept of a -1 and a slope of 3/4, which means up 3 and over 4. So from that point, 1, 2, 3 up, 1, 2, 3, 4 over. 1, 2, 3 up, 1, 2, 3, 4 over. Okay, and then I would draw my line through those. Got it. Piece of cake. Easy. Make that a blue line. Okay, so now let's graph the other one. We're going to do it in green. So, again, I have a slope of 3/4, which means up 3 and over 4, from my y-intercept of 1/8. Well, where is 1/8 on this grid? I can see a half, and I might be able to guess a fourth, and maybe an eighth is right there, but I don't know exactly where 1/8 is. Really hard to do on this grid. Now, what I could do is redo the whole grid where each little square is 1/8 of a unit and do the whole thing. Now, if I did that, this point right here would go down 1. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Now that's 1. So there's -1. 1, 2, 3, 4, 5, 6, 7, 8. There's +1. 2, 3, 4, 5, 6, 7, 8. There's +1. 1, 2, 3, 4, 5, 6, 7, 8. There's negative. So I really zoomed in. So there's my -1, and I still go 1, 2, 3 up, 1, 2, 3, 4 over, 1, 2, 3 up, 1, 2, 3, 4 over. That part's going to be the same. I'm just going to do it by 1/8 of a unit instead of 1 full units. So now I can go ahead and graph the green one here and put it right at 1/8 and go up 1, 2, 3 and over 1, 2, 3, 4 and up 1, 2, 3 over 1, 2, 3, 4. And now I can have the line again. So there I have a line. Let's make it green because I was doing that one in green. Okay, so there's my two lines. They both have a slope of 3/4, and one's passing through the +1/8 and the other is, okay. So now what I need to do is figure out what is the distance between these. Well, according to the theorem, let's go back to that theorem or that key concept here. The distance between two parallel lines is the distance between one of the lines and any point on the other line. So any point on that other line is going to work. So that means I can do the distance from the green line to any point on the blue line. And that may not be a bad idea. Let's use this point because it's right at a corner and we already know what that value is and we can work it through. Or we can use any point along this. Now here's the thing. We know the slope of both of these lines is 3/4. So the slope of our perpendicular line has to be a -4/3. So maybe it'll be easier to start from a green one and go down. So if I start here, I would go down 1, 2, 3, 4 and go over 3. 1, 2, 3. Down 1, 2, 3, 4 over 1, 2, 3. Down to there. So now I can sketch in that line segment that connects those two. And I can actually shrink it up so it's just on that line, just like that. So that's the segment I need. Now, it doesn't matter where this segment is along the graph. I just have to be able to find something that's going to work. Well, this one might work. The question is, what is this point? Well, that's halfway between 1, 2, 3, 4 and 5/8. And it's halfway between 1, 2, 2/8 and 3/8. So that point there looks like it's a negative 4/8/16, 8, 9, a negative 9/16, and it was between 2 and 3 going down. So that's 4 and 6 and negative 5/16. So I need to take that point, and my other point was right here at 0, -1, and run that through the distance formula. Sounds like a piece of cake to do. Now there is another option. The other option is this handy dandy fancy little put it together formula. Okay, so now this one here says that the distance, define the distance between a point and a line or between lines, use the formula for the distance between the point x1, y1 and the line ax plus by plus c equals 0. Notice this part right here to begin with is that the equation of the line has to be equal to 0. And a, b, and c we want to be nice whole numbers. We want them to be nice whole numbers. So let's take our two equations again. Can I get them by themselves? Yes, I can. I'm going to clone them, throw that all the way down with us. Okay, so here's what I'm going to do. Since this one here is easy to find a point on, we know the point is at 0, -1. I'm going to let that be my point on this top line. So I'm going to use the point from that line, and now this one I need to turn into the form of ax plus by plus c equals 0, where a, b, and c are integer, whole numbers. So the first thing I'm going to do with that equation is I'm going to multiply that whole thing by 8. That's going to get rid of the fractions. So I got 8y equals 3x, sorry, not 3x, 3/4 times 8 would be 6x plus 1. Now I'm going to move the 8y to this side so that way I can get it to be 0. So now I've got 6x minus 8y plus 1 equals 0. So there's the equation of my line. There's the point I want to use. There's the formula I'm going to stick it in. So it says to take the absolute value of 6 times 1 times 0 plus, or minus, because it's a minus down here, minus 8 times 1 plus 1, that's all an absolute value, all over the square root of 6 squared plus 8 squared. So my distance between my two parallel lines is sitting right there. Well, 6 times 0, I'm just going to grab that stuff now. And I'm going to group it. And I'm going to move it down here. So now we can do the math. Okay, so absolute value of 0 minus 8 plus 1 all over the square root of 36 plus 64, which gives me a -7 inside my absolute value and a 100 inside my square root, which gives me a 7 inside coming out of my absolute value and a 10 in my denominator. So the distance between our two parallel lines is 7/10. Okay, so we could have continued it with our graphing method up here. And if we have used those two equations, I'll show you the answer. But before I show you that exact answer, realize first off, this point here was just an estimate. We didn't know exactly what it was. Okay, I noticed I made a mistake down here when I was looking things over. That was supposed to be a -1. So that should be a +8. So this number in here should be a +9. So this should be a +9/10, which is 0.9. Okay, so now what I had to do to get this to work out a lot nicer is I went onto the computer, I used the Desmos graphing calculator, and I clicked over here in this spot here, and it gave me this point as a location. So then I used that point with our 0, -1. So I used those 2 points, and I ran it through the distance formula, and I got a 0.9. So here's the thing. The actual point where those two lines crossed when I left the -1 point on the y-axis was a negative 0.54, which is like a negative 27/50th. We said 9/16. So we were off by a little ways, about 2/100ths off. And that's the problem with doing it that way. So using the second method of using that formula would be good. I would say definitely get this written down in your notes. So what do you have to do? The assignment, number 33, is on page 163, I believe. Yes, 163. And it's problems 19 through 20 all. 19 through 24 all, excuse me. And then problem number 28 and 29. Okay, that's what you get to do.